For part G, it gets even a little bit more elaborate. So we know what to do if our limits are in the wrong order now from part E. We know what to do if one of our limits is actually a function and not just a variable. Now we want to know what we do if both limits are functions, or even if one limit is a variable and one limit is a function. There's variables involved in the top and the bottom is the big thing here. So let's see. We still want to see that ignoring the upper and lower limits, we are finding an antiderivative, let me even not block off that much, of this function at some point. So what's going to happen here, I'm going to go straight to the step-by-step for this one instead of trying to just jump right to the answer, because I don't think you'll stick with me for that. I think you'll get a little bit confused. So I want to take the derivative with respect to s. First thing I need to do is find the antiderivative. I'm going to call it big F of p. So again, this is sort of an exercise in can you walk through the process, and also do you recognize that when you take the antiderivative and then take the derivative, you're going to get back to the original function. So we have this big F of p, which is the antiderivative of the square root of 1 plus p squared. Okay, and then we need to evaluate at root s and natural log of s, and then take the derivative. So notice, because both of these have variables, we don't just get to cross one out and say, oh, well, that goes away. So f of the square root of x, we take the derivative of big F, and we get back to the square root of 1 plus p squared. But we're not plugging in p anymore. We're plugging in the square root of s. And then we do need a chain rule because that inner thing is not just a variable, it's a function. So we're going to multiply by the derivative of the inner function. See if I can sneak this in here. Here, we're going to go like this. Over 2 root s. Okay. Minus big F prime, right? So here we're getting, for here, we get big F prime evaluated at root s times 1 over 2 root s. Here, we get big F prime evaluated at the natural log of s times derivative of natural log, which is 1 over s. So we're going to have a 1 plus natural log s squared over s. And that's our answer, that big ugly mess. There is a little bit you can do to think about this in the other way without actually having to go through the entire step-by-step. So if we want to think about this with derivative properties, I'd say this doesn't just look like an area function. It doesn't even just look like an area function composed with something else. We've got upper and lower limits varying, both are functions. But I do have properties that say, I could claim that this is the same as going from let's say like 1 to the square root of s, and I'm just pulling that 1 out of the air. There's nothing special about it. I did look for a second and try to pick something that's in the domain of all three functions, so the thing I'm integrating, the natural log, and the square root. So I didn't really want to say a negative number because that doesn't make sense. I don't even want 0 because that doesn't work for the log, but pretty much whatever else you want doesn't matter. Just pick a point to split this up. And then, what are we doing, 1 to s? Oh, you know what, I'm probably writing this in a confusing order. This works, but I'm just going to switch orders. Let's say we go from the natural log of s to 1, and then we go from 1 to the square root of s. So we get to this. The second one is very similar to what I had in part F. The first one still maybe is a little bit tricky because area functions like to have the constant in the fixed point in the bottom and the variable in the top, in this case function, which is not quite ideal but still works. So we could switch the order on those and throw a negative out in front, and we should get what we want from here. And then the minus stuff comes from here. So you can walk through it in that way as well. Okay, so last but not least, wants us to just really think about that generally. So here, I'll go through it in the second way that I did there, since I think the first way we walked through pretty thoroughly. So we want to take the derivative. This doesn't quite look like a construction theorem function or even a composition with a construction theorem function. So first thing I'm going to do is say, well, let's split it up. Let's go from g, the integral symbol first helps. Integral from g of t to, we don't know anything about domain, so I'm just going to say 0 of whatever function we're starting with. And then we're going to go from 0 to h of t, whatever we're starting at. And again, the 0 is getting entirely pulled out of the air. There's no reason I'm picking 0. If I knew anything about domains of f, g, and h, I would try and pick things that were in the domain, but I'm just going to hope. In fact, if you want to be more general, you could just say A. Oh, geez. Finally decided to erase and it stole my A. So whatever you want there. This is pretty good, except g of t to a is in the wrong order, so we could switch it back. And we could say that's negative integral from a to g of t of f plus the integral from a to h of t, little f. And then we're basically using the thought process we did above. This is an antiderivative, not including the plus. This is an antiderivative of little f. So when we take its antiderivative, we're going to get back to little f. So the derivative of the antiderivative just gets us back to little f. But we're going to have a little bit more to it than that, because we're going to have a little f of g of t, and then we'll have to multiply by a g prime of t, and the negative sign is going to carry through as well. So if you want to write in the extra steps here, it would be, okay, the antiderivative is big F. We would need big F evaluated at g of t minus big F evaluated at a, and then we would take the derivative. So the derivative of big F of g of t is little f of g of t times g prime of t, this minus sign still carrying through. For the second one, we should get something really similar. So we should get big F of t. When you take the derivative of an antiderivative, you get back where you started, only it's not t anymore. Getting ahead of myself. It's h of t. And then we'll have a chain rule because that's a function and not just our variable. And that looks like a great answer. Again, if you want to see a little bit more step-by-step here, I would say, okay, well, I would first find the big F formula, and then I would plug in h of t, and I would plug in a, and I would subtract, and then we're taking the derivative of that, so again, this d dt way out in front applies, and that's why we're getting little f of h times h prime. The derivative of big F of a is just going to be 0. All right, thanks for watching.